In this problem, it's asking determine the line L of intersection of the planes F1 and F2, whose equations are these two. So if I have plane 1 and plane, and sorry about that, and a second plane here, and then they intersect in a line over here. So what's happening is that we will have one normal N1 and then another normal N2. Guess what? N1 and N2 are both orthogonal to this line as well. So basically, if I want to find the direction vector in here, I should cross N1 and N2. So let's see what's N1 and N2. N1 comes from here, so N1 is, and N2 is. And so N1 is going to be 2, -3, and 5. N2 is 3, -4. Okay, no Z, so 0. And so to cross these together, N1 cross N2, okay, 2, -3, 5, 3, -4, and 0. For I get 0 minus 20, which is going to be equal to 20. Then for J, I cover here, and I get minus 0 minus 15, so it's positive 15. Then for K, I'm covering here, and minus 8, minus 9, which is plus 9, and that's 1. So that becomes my direction vector V. So I have a direction vector V, which is what I found. I still need a point for the line. So how do I find a point? And that becomes a question of solving systems of equations. So if this system of equation, and it gives me multiple solutions, and the reason for that is because basically this has infinite, it turns out that it has infinite solutions. There are two planes in here that are intersecting each other, and they are not parallel. That's why they're intersecting each other. And that's is going to be an equation of a line. So there are infinitely many solutions. And what I can do is basically maybe solve for x in here and then plug it back in there. So solving for x in here gives me 3x equal to 7 plus 4y. X is 7 plus 4y divided by 3. And then you plug it back in there, and you get 2 times 7 plus 4y divided by 3, minus 3y plus 5z equal to 1, and that's 14 third plus 8 third of y minus 3y plus 5z equal to 1. Now, I can basically, I can say that z is equal to t, then plug it back in here as the parameter, and then find the y value. So choosing the z as a parameter t, then I can also solve for y in terms of t. Let's clean this up. 1/3 minus 3 is negative 1/3 of y. Add 14/3 to the other side will give me, it's going to give me minus 11/3. And then I can plug all this back and solve for x. Maybe over here. First let's plug in the t. So I get minus y/3 is equal to minus 11/3 plus 5t, or y is equal to 11 minus 15t. Now from here, I can solve for z, put it back in there, and for x, I'm sorry, and x is going to be 7 plus 44 minus 60t over 3, which is 51 minus 60t over 3. Now I just need 1 point, and so I plug in t equal to 0, and over here I get 11, and over here I get 51 over 3, which is basically 17. So now, so the point t equal to 0 gives me 17, 11, and 0. This was the direction, that's a point. So this is P on the line. Now, all I need to do is basically use the point in terms of OP, which is 17, 11, and 0, position vector. And then R of T is going to be 17, 11, and 0 plus T times direction vector. Position vector, direction vector. And that becomes my equation of the line. One thing that I want to mention, the way that we solve this and what we got from this section, kind of messy, but so 51 minus 60t divided by 3, which is 17. That actually simplifies, but let's just ignore it for a minute. Minus 15t and t. This is also equation of this line using somewhat a different direction vector, not a whole lot of different direction vector. That's going to be 17 minus 20t, 11 minus 15t, and t. So what you're doing as linear algebra or college algebra is also finding the intersection of these two.